few moments later.
This road safety audit focuses on the critical campus connector road segment starting from the internal roundabout and progressing towards College and Greek. The primary area of concern is a distinct vertical curve section that introduces immediate geometric and operational challenges. First, the vertical crease drastically limits the sight distance for the drivers coming off the roundabout. Second, there is a discrepancy between vehicle speeding and the geometric layout. Vehicles exiting the roundabout often maintain speeds that are unsafe for the sudden vertical shift. Furthermore, there is a lack of adequate visual aids to warn drivers of the impending crease. Plus, the drainage gutters are completely filled with leaves and debris.
Drivers consistently fail to stop or yield to pedestrians utilizing the crossing even though there is an advanced pedestrian warning signs. To investigate the safety and operational characteristics of this curve layout, we are executing two interconnected studies which are a spot speed study and a traffic volume study. For spot speed study, our selected apparatus is laser gun. We randomly selected the samples. For example, the observer recorded a speed reading for every third vehicle or every fifth vehicle. We observed the vehicle speeds for a duration of 1 hour. For traffic volume study, our apparatus setup consists of a mechanical hand tally counter, a digital stopwatch, and a customized classification volume datasheet. Setting up continuous recording divided into 15-minute intervals.
We conducted a spot speed study capturing a total sample size of 112 vehicles. From the frequency histogram, majority of vehicles travel between 20 to 29 km per hour. From the cumulative frequency curve, the 50 percentile, which is median speed, found at 20.7 km per hour, meaning half of the campus travels below this speed. The 85 percentile, which is operating speed, found at 36.4 km per hour, which represents the safe operating speed under current condition, and the 98 percentile, which is design speed, found at 28.38 km per hour. Our data shows a standard deviation of plus minus 7.57 km per hour, demonstrating the variation in driver speed approaching the curve. The model speed, which is the most frequent speed, is 24.5 km per hour, which is within the speed limit of that area. Data collection occurred over a 1 hour period. Divided into 15-minute intervals, the data shows that the traffic steadily increased throughout the hour. The count started with 155 vehicles in the first 15 minutes, which rose to 165 and then 178 vehicles. Traffic peaked sharply in the fire interval with 267 vehicles, bringing the total hourly volume to 765 vehicles. An analysis of vehicle types shows that private transport clearly dominates the route. Passenger cars make up the largest portion at 58.3%, followed by motorcycle at 39.87%. Commercial and large vehicles are rare. Light vans and medium lorries each account for just 0.52%, and buses make up 0.78%. No heavy lorries were recorded during the study. To standardize these different sizes, the figures were converted into passenger car units, PCU, resulting in a total traffic volume of 1,242.5 PCU per hour.
At this location, we have identified three critical issues that require immediate attention. First, the main concern is a clogged curb drain along the roadside, which restricts stormwater flow and can lead to localized flooding. To mitigate this, we need to ensure regular cleaning of the drains and install debris traps to keep the water flowing smoothly. Second, there is a pedestrian fall hazard where students are at risk of slipping or falling when using these walkways. We recommend installing guardrails here to significantly enhance pedestrian safety. Finally, the drainage inlets themselves pose a structural issue due to a lack of regular inspections. Heavy vehicles frequently passing over the area can bend and damage the metal grids, creating several safety hazards. To address this, we must implement a routine inspection schedule and replace the damaged section with heavy-duty, load-rated drainage covers.